Well, hello, my friends. Welcome back as we continue our journey through an introduction to probability. In this video, we're going to examine the algebra of sets. We will start out with this, an understanding that every mathematical system has truths that guides its operation, and sets certainly have truths that guide their operation. We've looked at such things as the complement of sets. We've looked at union of sets, intersection of sets, talked about disjoint sets. We've looked at partitions of sets. Now we simply need to learn some of the algebra of sets as we work with complements, unions, and intersections. So we will establish these mathematical truths. First of all, let's start with a symmetric property. And notice that we have a symmetric property of union and a symmetric property of intersection. All this says is that S union T is equal to T union S. So it doesn't matter in which way we approach a union of two sets, we still get the same answer, and the same being true for the intersection. S intersect T equals T intersect S. Now, we also have what I call a distributive property of union, and we have a distributive property of intersection. Let's examine that just a minute. S union, the intersection of T and A. We would do the intersection of T and A first in this, then union it with S. S union, the intersection of T and A, is S union T intersected with S union A. And we have a similar distributive property for intersection. S intersected with the union of T and A is S intersect T unioned with S intersect A. So we have properties of symmetry, symmetric properties, and we have distributive properties. As with every mathematical system, sets have truths that guide their operations. We have the associative property. We can take and union T and A, then union it with S, and that's the same as union in S and T, and then union it with A. The associative property. They can associate in whichever order they want to. The same associative property of union and an associative property of intersection. We will continue here, and this is one that's very interesting. The complement of a complement is the initial set. Now think about that. S complement is everything in the universe that is not in S, and then everything in the universe that is not in the universe excluded from S. The complement of S complement is S. This is kind of like saying that a negative negative is a positive. As a matter of fact, that's a very similar argument. More rule statements, and these are just identities that we will try to represent with pictures. S union with S complement is the universe. Let's see if that's true. Yes, if we take S and we union it with everything in the universe that is not in S, we get the universe. S union S complement is the universe. Then we have another one. S union the universe is the universe. Look at that. S union with everything in the universe is the universe. And then another one. S union the empty set is S. Let's look at that. S unioned with the empty set is indeed S, because there's nothing in the empty set to add to S. So S union with the empty set is simply S. Let's look at some of the intersection rules. S intersected with S intersected with empty set is the empty set. Let's look at that. What do S and the empty set have in common? Well, absolutely nothing. Fairly cool. We have S intersect the universe is S. If we intersect S with the universe, then all that we have is S. And then I want to thank you for your support. This has been kind of fun. I mean, you've learned symbols, you've learned terms, you've looked at Venn diagrams, you're beginning to get a sense of pictures. So I hope you've enjoyed this. And I remind you that these videos are brought to you by the AURAC Teaching and Learning Center. You have a great day.